Welcome to recording 1B in our series on trigonometric ratios of any angle for Unit 2, Chapter 2, Trigonometry, Mathematics 2200. In this recording, we'll be focusing on determining the sign of a given trigonometric ratio for each quadrant. Quick recall. If I give you a point, or if you're given a point on the terminal arm of an angle theta in standard position, the sine value for that angle is y over r. The cosine value is x over r. The tan is y over x. We learned that in the previous recording. Now we're going to determine a quick rule, a way to quickly remember in which quadrant each ratio is positive or negative. We begin by taking a look at the points in each of the four quadrants, the signs of the points. So for example, right here, the x value is always positive and the y value is always positive in the first quadrant. So for our value of sine, it will always be a positive divided by a positive, which equals a positive. The cosine value is the x over r. And remember, r is always positive as well in any quadrant because it represents the radius of the circle. So x over r is a positive over a positive, which is once again a positive. The tan of theta is y over x, which is once again a positive over a positive. Notice in this diagram I haven't marked any thetas in there because it would be too confusing. I've just shown the terminal arms. So tan is positive. All of them are positive in the first quadrant. In the second quadrant, the x value is negative, the y value is positive. So the sine y over r will be positive over a positive, which is a positive still. The cosine value will be a negative because we have the x value is negative, y value is positive, so we have a negative over positive, which is negative. The tan value will be y over x, positive divided by negative, which is a negative number. So the only one that's positive in that quadrant is sine. Next, quadrant 3. Both the x and the y are negative numbers. So as a result, the sine value will be a negative because the y value is negative over the r value is positive, which gives you a negative number for sine. The cosine value, x is negative, y value is positive, so we wind up with negative for the cosine value. The tan value, tan theta, will be y over x. It's a negative over a negative. Negative divided by a negative will equal a positive. So the only one that turns out to be positive in this quadrant is tan. For quadrant number 4, the x value is positive, the y value is negative. So applying the same reasoning, sine negative over positive because the r value is positive again. And therefore we get a negative value for sine. Cosine is x, which is positive, over r, which is positive, which is still positive. And tan will be y over x, negative over a positive, which is a negative. So the only one that turns out to be positive in that quadrant will be the cosine. Give it a try. Cosine of 320 degrees. I bet you get a positive result, whereas the tan of 320 degrees, you'll get a negative result. We have now our cast rule. Some people know it as add sugar to coffee, but cast, C-A-S-T, summarized for you right here. Cosine, all, sine, tan. It tells you which of the three primary ratios is positive in each quadrant. Let's use that result. If theta is an angle in standard position, in which quadrant does the terminal arm lie if the sine of theta is positive? Greater than 0 means positive, and the cosine of theta is negative. So using our cast rule, C-A-S-T, sine is positive in either the first quadrant or the second quadrant, but out of the two, cosine is negative only in the second quadrant. So our correct answer here is quadrant 2. Next example. Without using technology such as a calculator to determine if each ratio is positive or negative, 300 degrees. Let's see where 300 degrees lands us. That's in quadrant number 4. Rotation is 300 degrees. According to this cast, only the cosine is positive in that quadrant. Therefore, tan is negative. Tan of 300 degrees is negative. For the next one, 155 degrees, again we sketch. Puts us in quadrant number 2. That's the place where only sine is positive, according to cast. So cosine of 155 degrees is negative. Last example. If sine theta equals negative decimal 1325, where theta is an angle in standard position, determine the possible quadrants for the terminal arm. Well, the sine value is negative. Out of the 4 quadrants, it is negative in either quadrant 3. We don't know the exact placement because we don't have enough information yet. And quadrant number 4. So those are the 2 possible locations for the terminal arm. So theta could be here, or it could be all the way as far as here. Quadrants 3 or 4. To conclude, cast is a technique for quickly determining the signs, positive or negative, of the trig ratios in each quadrant.